Today, we're going to talk about a groundbreaking paper that really challenges one of the most common and what we thought was one of the safest breast cancer diagnoses. The research suggests that for decades, we may have been looking right at a killer hiding in plain sight. And that brings us to this big puzzle that has had researchers scratching their heads for years. We all know mammography and early detection are incredible, life-saving tools. But here's the thing. Even with regular screenings, some breast cancers are still fatal. So why is that happening? What piece of the puzzle are we missing? And let's be clear, mammography has been a huge success. The paper we're looking at points out that modern screening has led to a 40 to 50% drop in breast cancer deaths. I mean, that is a massive achievement. But it also makes those remaining fatalities all the more frustrating. And that's exactly where this new research comes in. To really get to the bottom of this, we have to look at one of the most frequent diagnoses that comes out of a mammogram, a diagnosis that honestly sounds pretty reassuring when you first hear it. It's called ductal carcinoma in situ, or DCIS for short. And the keywords here are in situ. It's Latin for in its original place. The official definition calls it non-invasive or stage 0 cancer. The language itself, in place, non-invasive, stage 0, it all makes it sound contained, localized, and not something to panic about. So all of this leads doctors and patients to a really specific assumption, that DCIS is basically a pre-cancer. It's seen as this problem that's neatly confined inside the breast's existing duct system, a problem that, by its very definition, can't spread. But what if that entire assumption is just fundamentally wrong? And this is exactly where the paper's research turns everything on its head. It suggests that a very specific and very deadly type of cancer is being mislabeled as this harmless DCIS, a cancer that is anything but in situ. This quote from the researchers just nails the problem, doesn't it? The words we use actually shape the treatment. When you call something non-invasive, it leads doctors to believe it can be managed that way. But for a certain group of patients, the evidence is now showing that this is a catastrophic mistake. So the paper zeroes in on this process called Neoductgenesis. Now, forget that image of cancer cells just sitting quietly inside old ducts. This is the complete opposite. This is a cancer that is actively building its own highways, a whole new network of duct-like structures that aggressively invade all the healthy tissue around it. It is not staying in its original place at all. It's on the move. This chart right here really gets to the heart of it. On the left, you've got the myth of DCIS, contained, non-invasive, localized. But on the right, you have the reality for these specific tumors, which the authors call ductal adenocarcinoma of the breast, or DAB. It creates new, invasive pathways. It is invasive by its very nature. And yeah, as the research confirms, it can and does spread. Okay, so if this deadly cancer is being mislabeled, how in the world do we find it? Well, here's the incredible part. According to the researchers, the key is already in our hands. It's all about learning to read the visual clues, these imaging biomarkers, on the mammogram itself. The number one most dangerous sign is a very specific pattern of tiny calcifications. On a mammogram, they look like fine, broken, branching little shards. The technical name is fragmented casting calcifications. And seeing this pattern, that should be a major, major red flag. You see, this pattern isn't just random dots. It's a direct picture of a really dangerous biological process. It tells you there's a cancer with central necrosis. That means the tumor is growing so fast, so aggressively, that its own core is literally starving and dying off. It is the visual footprint of those invasive neoducts we just talked about, and it's the hallmark of a highly aggressive cancer. Now, to really see the difference, let's contrast that with another, much less dangerous pattern. These calcifications are sometimes described as looking like skipping stones. You can see they're rounder, flatter, and more spread out. And these tell a completely different story. This pattern is linked to cancer cells that produce fluid, not ones with a dying core. There's no necrosis here, and it points to a much, much less aggressive type of tumor. Being able to tell these two patterns apart on a mammogram is, quite literally, a matter of life and death. So we have these visual clues, but does the data actually back it up? Well, the study connected these patterns directly to how patients did in the long run, and the statistics are absolutely mind-blowing. Just look at this. The cancers with necrosis, the ones with those fragmented, casting calcifications, they made up 58% of the cases in the study. Okay, so that's the majority. But now look at the deaths. They accounted for a staggering 76% of all the breast cancer deaths in the study. It's just completely disproportionate. Let me put it another way. The data showed that patients who had this specific necrosis-producing cancer had a 4.33 times higher risk of dying from breast cancer than patients with the less aggressive types. 4 times higher. That's huge. And if you remember one number from this whole thing, please let it be this one: 76%. 76% of all the breast cancer deaths in this study were in women who had those fragmented casting calcifications on their mammogram. This isn't some small, rare subgroup. This is the main driver of mortality that we've been failing to properly identify and treat. So the evidence here is just overwhelming. And that brings us to the paper's urgent call to action. Okay, what do we do now? Where do we go from here with this powerful new understanding? Well, the path forward seems pretty clear. First, the medical community has to recognize neoductogenesis for what it is, an invasive process. That means we have to stop using the single, misleading term DCIS to describe two completely different diseases. Radiologists need to be trained to use these imaging biomarkers to guide the diagnosis right from the start. Pathologists need to change how they analyze these extensive tumors. And finally, we need new therapies designed specifically to fight these aggressive, duct-forming cancers. This last quote from the authors really says it all. The key to saving more lives isn't necessarily some brand new wonder drug. It's a fundamental shift in how we understand the disease. We can't reduce the fatality rate of a cancer that we continue to misclassify as non-invasive. And that leaves us with this final, really provocative thought. This research suggests that one of the biggest leaps forward in breast cancer survival might just come from changing how we see it and how we name it. Could rethinking a single medical term and finally identifying this killer that's been hiding in plain sight be the key to saving thousands of lives?